In this video, I will talk about main tools for confidence interval and hypothesis testing for mean. Here are the definitions of statistic, parameter, and inferential statistics. Now, let's look at the notations for sample statistic and population parameter. Per proportion of sample statistic, we use p hat. Per population parameter, we use p. Per mean of sample statistic, we use x bar. For population parameter, we use mu. Variance of sample statistics, we use s square. And for population parameter, we use sigma square. And standard deviation, for sample statistic, we use s. And for population parameter, we use sigma. The main goal of finding confidence interval is to estimate population parameter from a sample. In any research problem, we have a population that we want to study. The measurements like mean and standard deviation are unknown, but we can always get a sample from population, and then we can do some statistical analysis on the sample and see how that relates to the population. This usually involves selecting a sample distribution. So a critical step here is to decide if we want to use Z or T distribution for sample. We will talk about that next. Whether to use Z or T depends on sample size and availability of population standard deviation. This chart here will guide us to determine whether to use Z or T. Looking at the chart, we see that when sigma is known, we use Z, and otherwise we use T. Also, we need to look at the sample size. When sample size is larger than 30, population does not need to be normally distributed, but when sample size is 30 or less, population has to be normally distributed. In this case, when sigma is unknown, we use sample standard deviation. Another thing that confidence interval calculations involves are critical values. These are the most commonly used confidence level. So let's find the critical values for each of them. First, let's look at 80% confidence level. Since confidence level is 80%, alpha will be 100 minus 80, which is 20%. We usually write that in decimal, so it is 0.2. And then alpha by 2 will be 0.2 divided by 2, which is 0.1. Now, let's try to find Z alpha by 2. We can use table, calculator, and Excel to find Z alpha by 2. So we are supposed to find this point here, Z alpha by 2. So first, let me show you how to find it using table. For a table, we look area to the left of Z alpha by 2. That means area towards the left. So this area. So now let me label this graph here. So we know this area in between is 0.80. This area is 0.10, and similarly this area is 0.10. So when we add these two areas, this one and this one, we get 0.90. So now let me pull up my table up on the screen. So here we will try to find 0.90 among these tiny 4 decimal place numbers. The value close to 0.90 is this one here, 0.8997, and its corresponding z-score is 1.28. So let me write that down here. It's 1.28. Now let's find Z alpha by 2 using calculator. So for that, let me pull up my calculator up on the screen. Then go to second distribution. Then we'll be choosing inverse norm. So use this arrow key to get down there and then select that. So here area is area to the left. which in this case is 0.80 plus 0.10, so it is 0.90. So let's type that there, 0.90, and our mu is 0 and our sigma is 1. So let's hit enter and enter. So this is what we got using calculator for Z alpha by 2, and it is exactly what we got using table also. Now let me show you how to find Z alpha by 2 using Excel. So for that, let me pull up my Excel up on the screen. Then you would be typing equals norm dot inv, then parentheses. It takes area to the left, which is 0.90. Mean is 0 and standard deviation is 1. Close your parentheses, then hit enter. So we have this number here for Z alpha by 2, and this is exactly what we got using table and also calculator. So let me put that over here, 1.28. Now we can fill out the rest of the table, this table here, in the same way. And we should get this. Next, we will talk about finding critical values for t-distribution. So we will look at these examples here. Here for the first problem, confidence level is 95%. That means we have 0.95 in the middle and alpha is 0.05. This means each scale has area of alpha by 2, which in this case will be 0.05 divided by 2. So that means this area here is 0.025, and similarly this area here is also 0.025. Now let me show you how to find the critical value using table. So for that, let me pull up the table on the screen. Now we will look at the column of 0.025. That means this column here. This column here, 0.025. And to decide which row to look at, we will look at degrees of freedom. That is DF, this one here. So degrees of freedom is given by the formula n minus 1, where n is sample size, which is 20. So in this case, it will be 20 minus 1 equals to 19. So we'll be looking at this row, 19 row. So the critical value here is this one, this number here, which is 2.093. Now, let me write that value down here. So the value for T alpha by 2 that we just found from table is 2.093. Next, I will show you how to get this critical value using TI calculator. For that, let me pull up my calculator up on the screen. Now punch second distribution, then go to inverse T, which is number 4 here. So this one, use this arrow key to go there, then select that. So it takes area to the left. So let me move my calculator so that we can see this diagram here. So here the area to the left of T alpha by 2 is 0.95 plus 0.025. So we can just type that there, which is 0.95 plus 0.025. And we know degrees of freedom is n minus 1, which in this case is 20 minus 1, that is 19. Now hit enter, then hit enter. So we got this number here, and this is exactly what we got using table also. Now let me show you how to find critical value using Excel. So for that, let me pull up my Excel up on the screen. Now you would be typing equals, then type in T dot INV dot 2t, then type in parentheses. Our alpha here is 0.05, then degrees of freedom, which is 19, then close your parentheses, then hit enter. This is what we got using Excel, and this is exactly what we got using table and also calculator. Now let's look at the second problem here. Here we have alpha equals to 0.2. That means area in the middle is 0.8. And area towards the each tail is alpha by 2, which in this case will be 0.2 divided by 2. So this area here is 0.1, and similarly this is 0.1. So that means we look at the column of 0.1. So this column here. And to decide which row to look at, degrees of freedom, df. So df is given by the formula n minus 1, where n is sample size, which is 15. So in this case, it will be 15 minus 1, which is 14. So this row here. So here we look at the row of 14, this, and column of 0.10, this. So that means the critical value is this number here, 1.345. So let me put that value here. So we just found T alpha by 2 to be 1.345. So this is by using table. Next, I will show you how to get this critical value using TI calculator. Let me pull up my calculator up on the screen. Now, go to second distribution, then go to number 4, inverse T. That is what we will be using. So here, area means area to the left, which is 0.8 plus 0.1, which is 0.9, 0.9, and degrees of freedom is 14. 14, then hit enter, then hit enter. Okay, so we got this using calculator, and this is exactly what we got also from table for the critical value. Now let me show you how to find critical value using Excel. So for that, let me pull up my Excel on these screens. Then we will be typing equals, then typing T dot INV dot 2t, then put your parentheses. Our alpha here is 0.2, then degrees of freedom is 14, then close your parentheses, then hit enter. So this is what we got using Excel, and this is exactly what we got using table and also using calculator. And finally, on this slide here, I have listed the answers for both of these problems here, and we are done. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.